Welcome to the Copernicus Data Space Ecosystem webinar, focusing on Sentinel satellite data in support of mountain sports and safety. This is the second of two webinars with the same focus. Today we will have Michael Engel as our guest, who will explain, among other things, how remote sensing data can significantly improve mountaineering safety and how simple web applications can already provide significant benefits in the management of hiking areas. There will be a question and answer session after Michael's presentation, so stay tuned till the end. And without further ado, Michael, I will hand the floor over to you.
Yeah, hi. Thanks for a nice introduction. So I'm Michael, and I'm currently pursuing my PhD at the Technical University of Munich at the chair of remote sensing technology. And in my leisure time, I'm love to go to the mountains. And I'm also guiding tours for college sports of Munich and for the German Alpine Club. And since this year, I'm also responsible for the trail management for the area around the Coburger Hütte, which is close to Zugspitze in Austria. And for all these things, so for doing my own tours and for guiding tours and for the trail management, I'm using satellite data a lot, and especially the Copernicus Data Space ecosystem APIs and interfaces. And to explain you why, maybe let's explain to you why I started, so myself, and why it's reasonable actually. And as you can see, you see a helicopter, and that's why I started. Because I had to get rescued as to a lack of knowledge of both the terrain and the conditions at that time. But what happened? So at the time, it was a sunny day in June. So a lot of sunlight during the day. We wanted to go to the Watzmann-Label, then cross the Watzmann-Scharte and descend within the Watzmann-Kahn. However, we started, it was pretty nice. We did a nice scrambling. Everything was going fine. We passed by the Watzmann-Label. We went up pretty fast. But starting from the Watzmann-Label, there was no path anymore, and it was pretty steep. However, it was still fine because at the day before, we even checked whether the conditions would be suitable. So that's the channel or the groove close to the Labelkopf. And as you can see here, the day before, so the previous day, we went to the other side and we even checked if the conditions would be fine. And we decided, okay, we have some snow within the groove, and which is favorable because then there is not so much rocks falling down from it or smaller stones or something because they are packed within the snow. However, as we continued, we noticed, okay, there's actually a lot of snow. And still, I was pretty confident because I knew from previous tours, if there's a groove, then we can use the snow, which is pretty, if you like it, you like it. If not, you don't, of course. But for me, I like these things, so it was pretty favorable. But then we arrived, so we continued. We arrived at Watzmann-Scharte and we noticed, hoopsala, the groove is not a groove and it's not a channel. It's more like a ledge. And as you can see here, so that image to the right is here. It's looking down here. It's going down for 60 to 70 meters, and it's not a groove. It's more like a ledge. And the snow was rather, rather hot at that day, and so the snow was more like very slippery. So we decided, okay, we don't want to do this. However, we also had the point that during the ascent here at this side, we don't had any mobile reception. So we decided, okay, at this point at Watzmann-Scharte, we had a reception, and there was snow coming down at both sides in a way. So that's been the spot we decided to call the rescue, and that's why we were flown out by helicopter. And as you can imagine, I really struggled with that, and I was awake for the whole night. I barely slept an hour or something because I checked and checked and checked if I could have known it better, if there is some source I didn't check. And still I came to the conclusion I would have probably decided the same way. And because I was missing two things, and the two things were very high resolution maps and recent satellite imagery. And yeah, long story short, then after that, I did my homework, and high resolution maps, it's actually rather easy to get, but at that time it was not able to get that data because you always need open data. And for example, for this data, the Bavarian Land Surveying Office published it in 2023 or something. And then you can see it's really precise. You can see every ledge, every groove, even cracks within the rock. And so it would have been possible probably to decide, okay, it's not a groove, it's more like a ledge-shaped landscape. Well, so, but with satellite imagery, of course, Sentinel-2, so the Copernicus Sentinel-2 mission, which is a two-satellite constellation, and they're providing imagery every 3 to 5 days, depending on the latitudinal position. And that's how it looks like, and that's how it looked like for this particular spot. And as you can see to the right, it's rather blurry. And there I said, okay, well, I don't know if at that point I would have known how to decide you based on this image. And that's how it started to pose the question. So the question arose how to interpret even blurry satellite imagery. And within the next years, so 2021 to 2023, or how I call it in the meantime, a leisure time study on how to use satellite imagery to not die as a mountaineer, I went all over the Alps, and I made tours, and I looked at satellite imagery before and after the tour. And what I found out for high season, for example, is, and you want to compare it, always outdoors and Sentinel-2 in advance and at the particular location. And therefore, the Copernicus browser is pretty useful, or the EO browser from Sentinel Hub, of course. And let me show you now. That's how it looks like. So that's the Copernicus browser. It's pretty easy accessible. You see, you even have a 3D model, and here you see true color imagery of that area in Switzerland, the northern Bernese Alps. Here's the Gauli Glacier, and it's looking pretty nice. To the left, you have the different layers. So you have your true color, which, as it's called true color, is the way you would see it with your human eyes, or even other layers. And one pretty interesting layer is the so-called shortwave infrared layer, which could be, for example, band 11, band 8, and band 4. And the important thing to get here is that even though you cannot see it with a human eye, it's still existing, and the satellite is measuring it. And we visualize it by visualizing band 11, so that wavelength of light with red color, band 8 with green color, and band 4, which would be visible by our eye, but as a red color, we visualize by blue color. And why should one do that? If you notice, you see that it's very colorful, and there's high contrast, and it's looking, very colorful. And you see here, for example, vegetation is green, water is dark blue, and everything which has to do with snow and ice has a cyan color, and it's pretty good. But let's see what we can get out of it based on a real life example. So on that day, we went down here, then we crossed the Gauli Glacier, went on there, and the next day we wanted to go up here, the Hubel Glacier, to Hubelhorn, and there we took an image, and I assessed it in the aftermath mainly. Here you have a true color image and the shortwave infrared image. Let's zoom in a bit, such that I can show you our route we took. So we went up, went to the right, went to the left, then we had to cross that rim here, then on the plateau-like thing, and went to the Hubelhorn summit. However, the most interesting part, or the most challenging part forever, has been this thing, because here you have glare ice. It's rather steep, it's up to 40 degrees, and we have to surpass it here to the right. So if you want to see the satellite image, so to assess the condition beforehand, you may have a look at the true color image, which is here, the glare ice. But if you look at the rock, which is down here, you notice that it's also a grayish gray color, which you cannot really distinguish within the true color image. And that's not so nice, because then you don't know if it's glare ice or if it's rock. But if you look at the shortwave infrared image, you see a clear difference. Here it's reddish color, and here it's dark cyan color. So I always propose, if you go within the high season to high altitude mountaineering, use shortwave infrared for this glacier assessment. Let's zoom in a bit. Because the question is now, as you can see on the image, which is taken on the same day as the satellite image, that's for sure. If we can see that rock looking up ice as well. And I mean, yeah, if you look really closely, you can. Here's the rock. If you look to the right, you can see the tight reddish spot. And it's really important that you practice this a bit, because you will get a feeling, and it's really reasonable to do this also after the tours. For example, then you could practice, okay, I want to localize this spot of glare ice, and it's here to the right, or the rocks falling down, which is a bit more advanced, because this small tiny landslide is not pure rock like it's down here, but it's pieces of rock on top of snow, and that's why you see it with a slight brown reddish line on the cyan snow. And then, actually, without knowing, so during making the presentation, I noticed this line here. So here, and I looked at the images from that day, and here, as you can see the small avalanche, which is a mixture of rock and snow. You can even see within the satellite imagery. And it's pretty important to practice this, and I really do recommend that, because then you get a feeling of how the conditions are by only looking at the satellite imagery without the necessity to rely on webcams or stuff like this. And apropos conditions, that's also a thing I want to emphasize, that especially for high altitude mountaineering, it's really important to get a feeling of how the condition of the ice is, if it's too hot, if it's melting a lot, if there's a lot of rockfall, icefall, and stuff like this. And as you can see here, to the left is 2021, to the right is 2023, and it's clearly visible that the snow coverage is way lower, and it's the 24th of August 2021 and the 24th of August of 2023. So it's really 3 years time difference in between. Still, well, you see, okay, there's not that much snow, but it looks basically kind of the same, except for the snow. But if you look at the shortwave infrared imagery, you will notice directly these bluish colors here, and also here, up there. And if you compare it, especially this area or that area here, you don't see the to the left image. And the blue color basically occurs if there is a lot of water. So if there's a high water content within the ice, or where is a bit of surface runoff of water on the glacier itself. So what did it tell you? It tells you that there's a high melting event on these glaciers, and you probably should not do too advanced stuff where you really need stable ice conditions and stuff like that. So that's what you can get out of that imagery. And of course, I know at the beginning it's rather hard to start doing this, because if that's the limit of visualization, so only looking at maps and then your imagery, okay, you need, as a starting point, you need to practice somehow to get a feeling, and that's what I can show you here, how you can do it. If you, for example, have if you have another service such as from Swiss Topo, you have a nice 3D model I can show you around. So it's in the northern Bernese Alps as well, and so Finster Ahorn, Jungfrau, Mönch, Eiger. pretty famous summits. And then, as Andra showed within the first episode of this webinar from Mountain Sports, you can go to your configuration utility, and then you take the WMS link, which you get as a service endpoint. You get here, you go, wait, at the beginning it's closed. It's looking like this. Then you go to Erweiterte Werkzeuge. Then you enter it here, and then you connect, and you, for example, choose shortwave infrared visualization, and then you can see, it's loading now, you can see the satellite imagery from the 24th of 2021. This could also be a more recent one. I just chose it to be that because I have the image, the real images there. And then you can lay the satellite image on the high resolution 3D model of the Swiss land surveying office, and you can have a look, and it's easier accessible, and it's really looking great. And if we go to the Hubel Glacier, we discussed before. Okay, that I was afraid this would happen because we changed the way you have to do it. No, not again. Anyway. So here's the Hubel Glacier again. I hope it will not flip away again. Anyway, and you see you have a really high resolution 3D model, and it's easier to understand this because now you have the terrain information in high resolution, and you get an easier feeling of the imagery shown. So much for the high season, but what about late season? Because time goes by, and after summer comes the autumn. And for example, if you want to do a grassy tour like this tour, so you want to go up the mountain and then you want to traverse all 4 summits. It's a pretty famous mountain in Allgäu. It's called Höfatz. And as you can see, there's a lot of grass, and especially in autumn season, the grass can be really colorful, really fiery, you could say. And that's what you can also try to assess within the Copernicus browser. Here I made a GIF out of it. It's a true color image, and if you look at this particular spot, especially where the route is going up in this area, you see the difference of September and October. And you see September it's green, and in October it's clear brown to reddish colors. And that's pretty nice. And we also checked it, and yay, it was a really nice day, and with really nice colors of the grass. But as you can already see in that image, especially that ridge here, it's a pretty steep grass. And in late season, so late summer or autumn season, it happens that there's a first snowfall coming. It's not permanent snow, but still there's a first snowfall. And it happened at the 13th of October. Here's a satellite image from the 18th. And we wanted to do the tour on the 24th. And so we had to discuss, okay, if there's still snow at these point here, because here you see the dark shadow areas here, and there we have to climb up. And if there's a mixture of grass and rock and there's snow, it's not the most convenient place to be, let's say. So the question arose, because looking at the imagery at the evening before, it was really dark and there was only shadow. And how to assess also shaded areas in the mountains, and how to see whether there's a lot of snow within or not. And it's also possible to do this within the Copernicus browser. And let me show this to you quickly. Here you can see the true color image again. You see the surface, so the interface. And here's the Höfatz. And well, you don't see because it's very dark. Let's get back, because we already know, to the band 11, 8, and 4. So the shortwave infrared imagery. And well, it still is even worse. So we're always using level 1 data. Andras already discussed this within the first webinar to that topic. But if you use the L2A scheme, for example, then it's atmospherically corrected. Okay, now I have to choose again here. No. 11, 8, and 4. It's always good to repeat. It's L2A, and L2A is basically atmospherically corrected, and atmospheric correction means also shadow corrected. And as to that, you see the shadow area is a bit brighter, and yeah. But if you say, okay, that's still not sufficient, you see here, so you see 11.8.4, and you show effects and advanced options. You click on it, and then you can adapt the value of gamma, for example, to 0.3, and of the gain to 0.6. And then it's even brighter within the shaded areas. So still, here it's a bit dark, but if we look here, which is the north face of the west summit of Höfatz, here's a tiny little bit of cyan color. So everything which has to do with snow, remember, is cyan color, and a bit cyan color. I'm not happy so far, so let's go to a similar mountain, which is here, Vischneck. It's also very grassy, very steep. And you can see here, okay, there's a bit of cyan color, but it's not as colorful as here. For example, here's clear snow. If you compare this area here to that area, you can see here's barely cyan color, and here's a lot of cyan color. So we decided, okay, we assessed it within the shadow. So for the traverse from the second summit to the third and the fourth summit. And so we decided to give it a chance, and let's see if it worked out. I mean, obviously I survived. And yes, there was a tiny little bit of snow, as you can see here, but it was only a tiny little bit. Still, it was not, to be honest, the most convenient ridge of my life, because here that spot was not so nice. But still, we assessed the snow coverage even within the shadow based on the Sentinel 2 imagery with atmospherically corrected imagery and using some settings for the visualization from Copernicus browser. And well, yay. And after first snowfall comes the next, and that's called winter. And within the winter season, it's always a transition. So as you can see to the right, the movie, it's from December to May, the Hohe Munde in Austria. And you see the snow is coming in with a high frequency. So it's kind of everything's white, and then it's melting rather slow. And that's basically the dynamic. And that's why it's always very dynamic. And you always have to consider avalanche reports and stuff to assess the conditions. Even if we look at the same thing in shortwave infrared imagery, you see, well, it's changing a lot. So how to assess the conditions? And at this point, I want to emphasize that first you have to read the avalanche report and do courses on how you deal with these things and stuff. So it's not sufficient to only rely on satellite imagery, but it's really, really beneficial because here, what is important for mountains like this, if you want to ski down, for example, and if we have a look at this mountain, it's actually rather steep. It's up to 43 degrees of steepness. And so what's important, so if you want to ski down that ridge here, or have a look at it from the other side, here it's probably better. Yep. If you want to ski down here, it has to be pretty stable because avalanches are obviously unfavorable. And yeah, so how to do this? Stable conditions for ski touring often depend if there has been a stable weather phase in advance. And you can see it in a satellite imagery. If, for example, have a look at, okay, I want to see only imagery with maximum of 30% of cloud coverage, and every date with a blue box surrounding it is an observation of a satellite with a maximum of 30% cloud coverage. So if there are a lot of them, for example, like in March, you know, oh, there has been stable conditions. And that's pretty favorable. And if you look, so from the 27th of February to the 12th of March, okay, next image, next image, next image, next image, and the next image. What you should have noticed is that the snow is slightly decaying, so it's melting. If you compare the second, here it's more cyan colored, and if we go to the 12th, the reddish spots are more clearly. And that's, but still, I know it's not that easy to see here, but down here it's easier. If you look here at the whole clump, then you can see it rather clearly. And that tells you, okay, there are stable weather conditions, and so the snow is melting a bit and it's getting more stable, so the avalanche danger is decreasing. And that's also very important if you look at the 3D model again, and we switch over data. So how does it look like? And it's pretty important to see these things. Here, you will get used to it if you practice it. Here is rocky slope. So here are rocks looking out of it, and here as well, and here as well. So what will probably happen is if you want to ski down here you will not go this way, because here you see it's a bit reddish. You will probably go this way. But then you see here the channel going down is a very long groove and a very steep groove, which you will not survive. So you have to go to the left here and then going down here. But let me show you how this looked like and how we assessed it. And here's the route we planned according to the satellite imagery. And again, the pictures are from the same date as the satellite acquisition. And here you can see, if you look very closely, you can see here a bit of reddish spots, and you see these rocks looking out of the snow. And if we take another picture here, you again see the rocks looking out the snow, and you see here the tiny red spots, the blurry reddish grayish spots within the camera viewing angle. Well, so far so good, but in winter it's even more complicated in a way, in the sense that there are more advanced topics like gorges, for example, because there's falling snow and falling ice, and you have to be really early to go through it. And as you can see here, so that's the gorge we had to get through on the morning, not at the time I took the image. And it looks like, in the satellite imagery, it looks like this. And here I want to emphasize the same as for the Hohe Munde. It's pretty good to have a look at the time series, because here you see from 5 days difference, so from the 22nd to the 27th of March 22, you see that the steep faces, the rocks here, they are first a bit of white and then they get darker, and that's a sign of melting snow. And of course, if snow is melting, water is flowing, and that's definitely something to consider. But that's not so easy. That's to see and to know. It's mostly based on experience. If you see such a melting event or things like this, you know, okay, you have to be careful within gorges and stuff, because if you fall into that water, it's not the best thing to do. However, gorges, the opposite, are ridges. And for ridges, the snow conditions are also very important. And especially after snowfall events, they are usually rather slippery, and if there is fresh snow and old snow, with fresh snow there are avalanches and stuff, or it's not so favorable. So it's also possible to assess this by looking at the satellite imagery or the time series. Here, put an example. So from the 4th of March to the 27th of March. And as you can see, on the 27th of March, where the rocks are a lot darker, so there's not that much fresh snow. And the image to the left is exactly on that ridge. So we had to go up here, so that ridge. And as you can see, there's snow on it, but the south side of the ridge is not covered with fresh snow, so it's easy going thing. And yeah, actually pretty nice. And well, so far to winter, because then the snow is melting and the early summer comes again. And at this point, in early summer, it's also very important for the trail management within the area. The German Alpine Club Coburg is responsible for, and where I'm now responsible for the trail management. So that's an image of it. So it's pretty nice, in my opinion. But maybe let's recap what we've seen so far. So we've seen that the condition-aware planning is crucial. We've seen that high-resolution data is rather easily accessible, so via open data initiatives by land surveying offices. And we've seen that satellite imagery is definitely easily accessible via the Copernicus data space ecosystem, for example. And we have three learnings. So the first thing, true color is easily interpretable without prior knowledge. If you remember from the Heufarts traverse, you have the fiery grass thing, and you only see it in true color image, but nice. But shortwave infrared imagery makes a lot of information easily visible. So if you remember the ice and rocks within a glacier and stuff like that, and time series allow to assess the ongoing processes like melting or snowfall events and stuff like that. And so at this point, for the trail management, we decided to implement an application which implements all 3 points with so-called SATCAM. And the SATCAM, I will just show you. That's how it looks like. So that's the satellite imagery from the 19th of June of 2024. And it's a combination of a true color image, because the grass is green and the rocks are gray and water is blue, and it's a true color image, except for everything which has to do with snow. And that's in a shortwave infrared. And by that, we have a combination of a true color image and shortwave infrared image, implementing all of the advantages. So it's easily accessible, easily interpretable without prior knowledge. And the high contrast of the shortwave infrared of snow things and rock things is still working. And we also have another mode, so the map mode, and that's how it looks like. So it uses the data from the Land Surveying Office of Tyrol and implements it. And now I want to show it to you in action. That's the webpage of the Coburger Hütte. And if you go to the webcam, down here is the SATCAM. It's loading. That's how it looks like. And many thanks to Copernicus Data Space Ecosystem. And that's actually the satellite image from today, which I haven't seen so far. Nice. So you can see it's always loading the first, so the most recent image. So from the 20th, from today. But here you have a time slider, so we could go back. The next one is from the 19th, which is on Saturday. And well, we can continue, and that's what we did, because so we allowed to change the time, because you should be able to see the process and see how the whole things evolve, so the melting and stuff. And for example, there's been a high snowfall event at the end of September, and that's how it looked like. And it was for the trail management. It has also been not so favorable, because here in that area we had to cut some trees because they were falling over the trail. But it's not really good if there's snow. And so, okay, we had to wait. And actually, it really worked, and it's not made up a story. So I was able to go to that area on Sunday, so on the 20th, only because I were able to look. Okay, I've seen the snow was not there anymore, and so I could say, okay, even if I would not live in Munich, for example, even if I would live in Coburg or other cities in Germany, I could say I'll have a look if it's possible to do the work I want to do. For example, if you want to do something here at the Grünsteinscharte, and if we look at June, for example, the 19th, so the example from the slides, you see, okay, well, if you want to put some marks, is it not loading? No. So if you want to put some marks so that people find the path, it would not be reasonable because it's still covered by snow. And all these things you can see looking at the satellite imagery. And if you want to have it in a higher resolution of a map, you can even see, okay, here is a path you have to put a mark for, but you will see shortly. And then it's loading the snow mask from the satellite imagery, and you can see, okay, that passage is still covered by snow. It's not worth going there and try to put some marks. And that's basically the application which I would have needed also from the quality of the map itself. So, I mean, if you have a close look, you can see really small stones, tiny rocks, and the paths you want to do. So it's really high resolution. And in a combination with the recent satellite imagery, I probably would have taken another decision for the tour in Berchtesgaden. And yeah, and that's basically it. And I really can only emphasize, look at these things, look at the satellite imagery and practice it compared to your experience when you go outside and stuff. And most important, keep your enthusiasm and stay safe. So thank you very much for your attention, and happy to answer your questions.
Thank you, Michael, for a really great and interesting presentation. I have to say it was really a pleasure to listen to you.
Thanks.
So let's check the questions.
Hey, everybody. Hi, Michael. Thanks for a nice presentation. One question I have is, how do you distinguish like the melting process from wind or other conditions could affect the snow surface? Because in fact of like avalanche hazard, it's important to check exposition and make the difference between melting processes on the south side or east side and wind, which could also blow away a snow surface and like let the rocks under it come to the surface that you can see it on the satellite imagery.
Yes, actually, so thanks for a nice question. It's actually a very good question. Especially for the Hohe Munde, it's pretty prone to wind, especially at that ridge. But if you look at it from high above, there are parts where wind plays not a big role. For example, down here within the gully, or here on the other side. So if you look at all sides of the mountains and the weather forecast, of course, you can see that the snow is decaying and getting less. I don't know if you, well, I have to find. Yeah, for example, if you go down here, you can see pretty well that if it has to load again, here's a lot of snow and it's rather low, so it's probably not that windy there. And there you can see that it's decaying. And probably since it's at the end of some gully system, there have been some avalanches and stuff, and that's why there's also rather much snow, but not as much as on the other. There's rather much snow for the height, but so you can see in the SAS the melting events there. But still, you're right. it's not always possible here on the ridges up there. It's only possible in a combination with the weather forecast, the avalanche report, and the satellite imagery. It's always good. But if you know that within the weather forecast there is a strong wind forecast, and then you look at the imagery, and if you look at the ridge up here and you see the reddish spots showing out of the snow, you can say, okay, wind did its homework, and wind, there was a strong wind blowing. That you can do. You can combine both the weather forecast from MeteoBlue, for example, and the satellite imagery. Does that answer the question?
Thanks.
Ignacio wants to ask if you use any additional data, so other bands, apart from the bands which you presented.
Usually no. So if we go back here, where I've shown what I'm using, so with shortwave infrared, and I'm basically always using band 11, band 8, and band 4 for the shortwave infrared, and for the true color, band 4, band 3, and band 2. And for me, of course, you could also use band 12, band 8, and band 4. But for me, rocks are more clearly visible within band 4, band 11 instead of band 12. So as you can see here, band 12, it's again more grayish, and if you use band 11, it's more reddish. So it's there's a higher contrast. So mainly I'm using, I mean, for private purposes, I'm also just, it's try and error. I mean, it's a process that you just have a look at the imagery. You could also use band 6 instead of band 8, but the resolution is lower. Be careful and assess for things like this. But mainly I'm using 4, 3, 2 as true color, and 11, 8, and 4. And if you want to do some stuff like indices, so if you go back to visualization, you can also have a look here at the NDSI, which is a snow, so the normalized difference snow index, and that's a visualization based on true color and also the shortwave infrared. It's similar to what we are doing for the SATCAM, but it's not exactly the same, but it's similar, and you can always click here. So here you see the NDSI, and you click here, and you can see the custom script, which is then here. And then you can even adapt it and program your own visualization and logic and stuff, how to, depending on what you want to see. Yeah, that's the thing. So I'm actually only using the bands you can see here and nothing else, actually. Except for the map version, now you were asking. For example, here, I mean, there are no clouds on that date, but let's see if we find some cloudy day. No cloudy day. Because there I'm using the cloud labels from the atmospheric correction. Okay, where it's been pretty cloudy, but you see the yellow color, and then also the snow thing is not working that good anymore. So if you see the yellow color, you can also see the clouds, and these are within the meta information of Sentinel 2A, but that's more advanced topic, let's say, to address. Yeah, I always recommend to look at the imagery first and at the map mode afterwards, because then you get a feeling, okay, how cloudy it is, and then you can see, and then you go to the map mode, and here you see the yellow thing for the colors, but also the snow. But you see there is probably something happening, and then just practice, just have a look at it. It makes fun a lot.
You can use Copernicus Data Space Ecosystem Forum for further questions. Stay tuned and follow us on social media for future webinars. Thank you all for joining us today. And again, one big thank you to you, Michael, and see you the next time.
Thank you.